My name is Danny Rioux. I am the new S02 reduction program lead at Teck Trail Operations, and I'd like to give you a bit of an update of what's been happening at the site in the last little bit. So maybe first off, a bit of a situation overview with Trail and S02. Now, Trail Operations at the moment captures greater than 99% of the sulphur that's released in our smelting operations. What that means is that the sulphur that comes in either through our raw materials or reagents, we either capture it in various products, sulfuric acid or fertilizer, for example. So basically over 99% of that sulphur is captured in products. So that would meet requirements for plant. At the moment, based on the permit amendment that happened in 2021, we're capable of meeting that permit amendment with the current process that we have and the operational controls that we've implemented. In the next year, there's a permit amendment that's planned for next year in 2023 with lower ambient targets. And we currently have some work, some new emission reduction projects combined with some controls, better controls to be able to meet that requirement. So I'll go into a little bit of detail on that in subsequent slides. The other thing about Trail Operations and where our plant operates, we do have some challenges around the topography of the Columbia Valley, and which limits some dispersion of the emissions, and try to show that a little bit what that looks like for us. And that means there's proportionally higher impact than in, say, more open terrain compared to, say, other plants in Canada, if I compare it to Sudbury or other ones like that. So maybe a bit of a picture here. Two things that kind of maybe want to talk about in terms of some definitions or glossary. When we're talking about emissions, we typically talk about what's leaving our stacks, and we typically discuss those in kilograms per hour. So you'll see that in subsequent slides. What you see in the top left corner, the picture that we have there is our six main sources or six sources of SO2 emissions from the site, coming from six various stacks, coming from six different parts of the process. And then at the bottom right there, there's a bit of a picture of the valley itself, kind of showing the height of the stacks comparison to the topography of the terrain. And then on site as well, or around the site, we have 4 ambient stations. So when we're talking about ambient levels, we're talking about the ambience at those stations. On the graphic at the bottom there, we show the Warfield station and the Butler Park stations, which are the 2 closest to the site. We also have one close to Columbia Gardens and one at Birchbank. When we talk about ambient readings, we typically talk about them in parts per billion, and you'll see that in a further slide as well. So this topography does cause us some interesting things to happen within the area, and the next slide would like to show you what I mean by that. So this slide has 2 graphs on it, and here I'd like to kind of give you an idea about the cycle and the changes that we have and what happens from an ambient level in the area. So the graph on the left shows the emissions from all our stacks combined in kilograms per hour. So that's what's on the y-axis. On the x-axis is really the time relative to sunset. And what it shows there is we have fairly constant emissions as the day goes from day to night, etc. On the right is the average ambient levels at all our ambient stations. So you see the 4 graphs or the 4 lines presenting our 4 ambient stations. And in parts per billion, and you'll notice there that when we take, this is the average values, I guess, for each hour of the day for 2021, that relative to sunrise, you get a spike between 3 and 5 hours after sunrise. And that has to do with meteorological conditions within the valley, either when we have inversions or lack of dispersion. So that brings a level of complexity for us to try to control. So maybe a little bit about SO2 emissions reductions and the work that we've done in the past, say, 8 years or so. So, when we embarked on this journey, we've spent some considerable investment to improve our emissions and reduce our emissions from the site, along with changes in operational control. So here I have a list of 3 main investments. Now in 2014 and 2019, as a sustainable capital or equipment change that we needed to do, we built 2 new acid plants that produce our sulfuric acid. And when we did that, we took advantage of changing those plants to slightly adjust the flow sheet, improve the technology to improve our SO2 emissions or reduce our SO2 emissions. And those two plants combined, we were able to reduce SO2 by about 100 kilos an hour. So the picture on the right side is actually a picture of our number 2 acid plant that was built in 2019. In 2018 and 2020, we have 2 furnaces that produce a little bit of SO2. And what we did there is we added a system to absorb SO2 from the gas stream so that we weren't releasing it to the environment. So we added what we call a continuous dry sorbent injection into a gas stream. And with adjusting, operational controls, we were able to reduce from those 2 sources approximately 165 kilograms per hour of SO2 being emitted. So that brought us to a target of around 440 kilograms per hour. And the current work that we're doing now is spending some time on a project in our lead smelting area called the KIFSET Feed Dryer Project, where we're looking at reducing a further 145 kilos an hour of SO2 to go from 440, that's the total emissions target that we have now, to once this project is operational, to be around 295 kilos an hour. So fairly significant reduction, which we've had in the last 8 years. So I'd like to kind of maybe speak a little bit about that project at this time. So what is this project? So in the lead side, before we put any feed into our lead furnaces, we need to dry it. So we have a feed dryer, a vessel, a dryer that enables us to do that. So what we've had to do, or what we're doing, is adding actually a second dryer to the system, along with gas cleaning equipment and other baghouse as part of this full project. And what that's enabling us to do by putting a second dryer in operation is going to give us the ability to change our process condition to significantly reduce the generation of SO2 during us operating that process. So overall, again, like I mentioned, a reduction of 145 kilos an hour of SO2, which is overall a reduction of a third of our emissions, total emissions leaving the site. At the same time, having these 2 dryers in operation is going to actually give us the capability to change our operational, or to change the way that we operate, to take into account this mid-morning peak level that we see after the sunrise, and be able to adjust the operation to reduce our emissions before that peak happens. And that will enable us to try to reduce the amount that we see at the ambient stations 3 to 5 hours after the sun rises. So this project is a $55 million investment. So it's a significant investment for us. We've been working at this for quite a while and had, some issues in terms of delays due to the global supply issues, which has delayed startup, i.e. end of construction and ready for commissioning towards early Q2 2023. That's still in a bit of flux, and we're still working to deal with the schedule and figure out the exact timing of us starting up this system. But it's been a bit of a challenge for us to get the materials here to complete construction. So what does that mean for SO2 ambient performance? I have a couple graphs here to show where we've been. On the left is we have the annual mean of all hours at our ambient stations. So the bars are actual or projected numbers for 2017, 21, and 2023. The green dashes are the permit levels. And then the 2 lines are the Canadian Ambient Air Quality Standards, the ones for 2020 and for 2025. So where were we in 2017 is what we're showing there. And we've had some improvements, the capital work and the operational controls I mentioned earlier, to get to where we are based on our actuals in 2021 and our projected values in 2023. So on the right side, the graph is a similar graph, except it's for the 99th percentile of daily maximums at our stations. This one, it's not an average of the station, it's basically the worst station that I'm showing here. And similarly, we've had improvements in terms of where we were and where we're going, although we still have some challenges to hit the Canadian ambient air quality standards, still a bit of ways from there. What's the next projection after that? So towards those ambient air quality standards for SO2, our annual averages projection for 2024 is that all our stations will be at or close to the 2020 air quality standards of less than 5 ppb annual average. And on the annual metric, our Columbia Gardens and Birchbank stations will be at or close to that 2025 air quality standard, but Butler Park and the Warfield stations will depend on the results of our feed dryer projects and modulation operations for those spikes. Although we're spending a fair amount of money on this project, we are still evaluating other opportunities for further SO2 emissions, and that's in parallel to our CO2 reduction planning as well. So that's, I guess, concludes a little bit of the update of the presentation I had for you.